9118A Thermocouple Calibration Furnace is a horizontal, open-ended tube furnace with a temperature range of 300 to 1200 degrees Celsius. It is used for comparison calibration of noble and base metal thermocouples by secondary high-temperature labs and instrument shops in industries such as aerospace, automotive, energy, metals, and plastics. Calibration tolerances for these applications are typically 1 degree Celsius or better. The 9118A is designed to meet the most demanding requirements of high-temperature thermocouple calibration. There are 7 key features that distinguish the 9118A from other high-temperature calibration furnaces. 1. Wide temperature range. 2. Flexible configuration. 3. Best-in-class temperature uniformity and stability. 4. Automated set point control. 5. Non-metallic block. 6. Deep immersion depth. 7. Dynamic heater control and cutouts. First, wide temperature range. Industry standards and guidelines require that a thermocouple be calibrated over the full temperature range in which it is used. The 9118A temperature range of 300 to 1200 degrees Celsius covers most high-temperature applications. Second, flexible configuration. The 9118A furnace can be operated with or without an isothermal block, which increases the calibration workload that can be performed with a single furnace. The furnace configuration can be quickly changed by selecting the calibration parameters stored in the controller for the desired configuration and inserting or removing the alumina-ceramic isothermal block. The 9118A without an isothermal block is configured as a tube furnace for calibrating base metal thermocouples. These thermocouples are often wrapped in materials such as braided fiberglass or PTFE. During calibration, they're bundled around a reference thermometer held together with fiberglass cord and inserted into the 9118A. Metal or ceramic sheathed thermocouples are normally built with noble metal thermoelements and have higher calibration accuracy requirements. The 9118A with an isothermal block improves heat transfer and stability. This configuration better equalizes the temperature between the reference probe and the unit under test, which lowers measurement uncertainty compared to a calibration without a block. Third, best-in-class uniformity and stability. Axial and radial uniformity, combined with a constant temperature stability over time, are key factors that contribute to accurate thermocouple calibrations. To minimize axial temperature gradients, the 9118A employs 3 independently controlled heater zones to compensate for temperature differentials between the central zone and the front and rear zones. Type S thermocouples, which are less susceptible to drift than other types, are used for zone control and cutout. The 9118A without the isothermal block has an axial temperature uniformity of 0.25 degrees Celsius. With the isothermal block, axial uniformity improves to 0.2 degrees Celsius. Radial, or hole-to-hole uniformity, is 0.5 degrees Celsius without the isothermal block. With the block, radial uniformity improves to 0.25 degrees Celsius or better. No other calibration furnace in its class comes close to this level of performance for both modes of operation. Fourth, automated set point control. The 9118A uses a proprietary programmable controller with user-selectable interface prompts available in 9 languages. The controller helps technicians improve lab productivity by automating set point temperature control for up to 8 set point temperatures, the time duration the furnace controls at each set point, and the temperature ramp rate. Automation and data collection is further enhanced when used with the Fluke Calibration 1586A Super DAC. When the 1586A is connected through the RS-232 interface to the 9118A, the Super DAC will control and monitor the 9118A set point temperature, read up to 40 thermocouples, and automatically collect data. The Super DAC will then advance the 9118A to the remaining programmed set point temperatures, collecting data at each set point along the way. Once the test has been configured and started, the technician can walk away to work on other activities. Fifth, non-metallic block. Calibration furnaces with metallic blocks can contaminate thermocouples, causing their accuracy to drift over time. To minimize the risk of contamination, the furnace tube and isothermal block are built from non-metallic ceramic alumina. This eliminates the need to protect thermocouples under test with costly ceramic sleeving, reducing cost of ownership. Sixth, deep immersion depth. Industry standards recommend calibrating thermocouples at their normal working depth of insertion. Unfortunately, not all calibration furnaces are created equal, and immersion depth is often insufficient. The immersion depth of the 9118A, however, is 365 millimeters when using the isothermal block and 350 millimeters to the central point of the furnace without a block. This immersion depth is adequate for most thermocouple calibrations. The total length of the open-ended furnace tube is 700 millimeters, which can be helpful when calibrating longer multi-junction thermocouples. And seventh, dynamic heater control and cutouts. Some furnaces include a spare set of heaters as part of the standard equipment, because heater failure is an all-too-common occurrence. The 9118A controls the heater power level below 100% to prevent the heater elements from overheating, improving heater reliability and extending lifetime. Redundant over-temperature cutouts are built into the 9118A to ensure safe operation of the furnace. These include over-temperature, chassis thermostat, fan fault, control thermocouple fault, and user-programmable cutouts. The 9118A Thermocouple Calibration Furnace, the most flexible, accurate, and reliable horizontal calibration furnace in its class. Please visit our website for more information.